In this video, I'm going to show you how to solve the Newton's second law problems using graspable math. So if you look on this slide here, you have the link for graspable math. This is the slide right before the problems start. Okay, you want to click on that and open up graspable math, so that way it is loading and you can go back and forth to it. Okay. And then there's also a video, the link to this video of me explaining how to do this. So let's get right to the problems. It says, how much force is required to accelerate a 2 kilogram mass at 3 meters per second squared? So 2 kilograms. Kilograms is telling us that it's a mass. So we want to write down 2 kilograms under mass. And it's at 3 meters per second squared. So meters per second squared is telling us that that's an acceleration. So we're going to write 3 meters per second squared. We can just put 2 for the acceleration. And then the next thing, we do want to fill in the force, but we don't know the answer to that yet. So we have to look over here. It says highlight the formula you will use to solve the problem. So if we're looking for force, you've got a choice of F equals M times A, M equals F divided by A, or A equals F divided by M. Since we're looking for force, we will be using the F equals MA. So I'm just going to highlight that and then put, you can use whatever color you'd like. I'll just use yellow. Okay. So that just tells me that you know which formula that we would be using to solve for that problem. So F equals M times A. You can use graspable math if you'd like, or you can just multiply the two numbers. Okay, I'm going to show you how to use it using the graspable math, but really it's as simple as just doing 2 times 3 in this problem. Okay, so we have to go back to the graspable math link. I have all the problems set up here for you, just like we've done in the past. If you notice, all of the formulas are in here, F equals MA for each one, so we can plug in our numbers. So we're going to take our M, plug it in for the M. We're going to take our A, plug it in for the A. I click my parentheses to get rid of them. Okay, and then we just have 2 times 3, which is 6. So we just go back to the problem, and under force, we're going to say 6. Now, the unit for force, which we've learned before, is a Newton, so a capital N. So 6 capital N. Okay, number 2, I'm going to do the first 5 for you. So number 2, what is the mass of an object that requires a 100 Newton of force in order to accelerate 10 meters per second squared? So we're looking for the mass, okay? It's giving us the force. The force is 100 newtons. The mass, we don't know. The acceleration is 10 meters per second squared. Okay, so in this problem, we're looking for mass. So we're going to use the M equals F divided by A formula. Highlight that and then make it yellow. Okay, and now we can go and use graspable math to solve the problem. So my force is 100. My acceleration is 10. Okay, click to get rid of my parentheses. And now I have to move my 10. Okay, I need to get M by itself, so I want to divide the 10 on both sides. So I divide it on the left side here, so I get 100 divided by 10. Double click on the line, and that gives me my answer of 10. So I go back to my thing here, and mass is 10, and the unit for mass is going to be kilograms. Okay. Problem 3. What is the acceleration of a 10 kilogram mass? So it's what is acceleration? So we know we're going to leave acceleration blank to start. And it's 10 kilograms. Kilograms tells us that's mass. So 10 kg. And it's pushed by a 5 Newton force. So 5 and force. And we're looking for A. So I'm going to highlight the acceleration. Go. And I'm going to use graspable math to solve the problem. So I plug in my force, which was 5. I plug in my mass. Okay, and now to solve for A, I got to click to get rid of my parentheses first. And it's 10 times A, so I'm going to move my 10 by dividing it onto the other side. So I get 5 divided by 10, which comes out to be 0.5. Okay. So So I go back over here. My acceleration is 0.5, and the unit for acceleration is m/s squared. Pretty simple. Okay, so 2 more examples. We got number 4, given the force of 88 newtons. So right away, I know that's 88 newtons, and has an acceleration of 4 meters per second squared. So 4m/s squared is the acceleration. So I'm looking for mass. So I got to highlight my mass formula. Now I jump to graspable math, and in here for this problem, it does not give us the variables, so we're going to plug them in. So I'm going to insert. I click insert and then math expression, and I'm going to say that the f, and f is capital, so capital F equals 88. Okay. I'm just going to move that up next to the problem. And the acceleration is 4 meters per second squared, so I'm going to put math expression a equals, and I make sure it's lowercase a, equals 4. And now I can just solve the problem. So I plug in my f, I plug in my a, click to get rid of the parentheses. Okay, and now I have m times 4, so I have to divide my 4 to the other side. You're always doing the opposite operation. Okay, so now we get 88 divided by 4. Double click on the line, and m equals 22. So I come back here and I type in 22, and it's mass, so it's kilograms. And the last example, okay, how much force is required to accelerate 12 kilograms? So that's the mass because it says kilograms. At 5 meters per second squared. So 5 meters per second squared is my acceleration. I'm looking for force in this problem, so I'm going to highlight my force equation. Okay. And now I use graspable math over here, so I'm going to, again, have to plug in my variables. So my acceleration was 5. And my mass was 12. Okay, so now I can solve. Put my m in. I put my a in. Click on my parentheses to get rid of them. And then you're just clicking on the dot to get them to do the math. So 12 times 5 gave me 60. Go back in here, and the force is 60 newtons. And that is how you do it. So the rest of the problem, 6 through 10, you can do on your own. Okay, 1 through 5, you can fill in just like I filled in. And good luck.